Hello friends, hope you all are keeping fine. In this video, you'll study a very important concept of 10th standard physics, electromagnetic induction. But before starting, let me narrate a story to you. One day, Hans Christian Ørsted invited Michael Faraday to his house for a lunch. Hans Christian Ørsted? I think you forgot. Let me tell you. He who discovered that electricity and magnetism are linked and showed by his experiment that electric current creates magnetic field. Happily, Michael Faraday accepted the invitation and went to Ørsted House to congratulate him for his discovery. Thus, after having a scrumptious lunch, Ørsted showed Faraday his experiment that when current flows through a wire, and wire is kept over the magnetic compass, the needle deflected. He concluded that a current-carrying wire produces a magnetic field around it, and thus electricity and magnetism are linked. After coming back from Ørsted House, Michael Faraday got puzzled. Thousands of questions popped up in his head. Faraday started thinking that Ørsted, through his experiment, just showed me how electric current produces magnetic field. But can magnetic field produce electric current? Can a magnet produce electricity? Can we produce electric current without battery? Suppose we have a coil and we pass current through the coil, then magnetic field is created around the coil. So this we understand that electric current produces magnetic field, but is vice versa true? He started doing blue sky thinking, conducted few experiments. Finally, he got the answer. Eureka! Yes, it's possible. Magnet can produce electricity without battery also. But how? Let me explain you. Faraday, in his first experiment, took a galvanometer, a magnet, and a coil, and connected the galvanometer across the coil. Galvanometer is a device which detects the presence of current. If no current flows through galvanometer, the needle of the galvanometer remains at zero. If current flows, it deflects right, and if direction of current reverses, then it deflects left. Now coming back to Faraday's experiment. So when Faraday moved the magnet towards the coil, the needle of the galvanometer deflected right. When magnet was at rest, there was no deflection in the galvanometer, so current was zero. And when he moved the magnet away from the coil, the deflection in the galvanometer was in the opposite direction. Thus, moving a magnet towards or away from a coil induces a current in the coil, whose direction and magnitude is given by the galvanometer. So this is what Faraday concluded from his experiment. First, current is induced due to relative motion between magnet and coil. Second, deflection is reversed when poles of magnet are reversed. And lastly, faster motion of magnet or coil